Before we move on to gases, I just wanted to go through, first of all, the term molar mass, and also I think a little bit more about what we mean by a mole or of a substance. So the term molar mass is the mass of a mole of a substance. So it's very similar to relative atomic mass, relative molecular mass, relative formula mass. It has exactly the same numerical value. You work it in exactly the same way. It's just it has units of grams per mole. So rather than us saying the relative atomic mass of carbon is 12, the molar mass of carbon is 12 grams per mole because there are 12 grams of carbon in a mole. Don't get too worried about this. It's just a different term, and it means that we can simplify our equation to moles equals mass over molar mass, and that works for everything. So we don't need to keep using these different relative masses. So we can just have that one equation from now on. So now we've got a bit of a better understanding of what a mole is. We need to think about using the correct terminology when we talk about a mole. So we need to think whether we're talking about a mole of atoms, a mole of ions, a mole of molecules, because that makes quite a difference in how we're going to deal with it. So let's look at these two pictures here. So in the picture on the left, you have got 4 atoms of oxygen. And in the picture on the right, you've got 2 molecules of oxygen. And they're molecules of oxygen because you've got 2 oxygen atoms chemically bonded together. So hopefully you're happy with that. So let's have a think of that in terms of moles now. So if we want to think about these particles in terms of moles, it just means we have a lot more of them. So again, we can have a look at looking at oxygen, for example. So if I had 6 times 10 to the 23 of oxygen atoms, I would have a mole of oxygen atoms. And if I had 6 times 10 to the 23 of oxygen molecules, I would have a mole of them. So I would just have far more particles that I would be dealing with rather than one molecule and one atom. I would have a mole of molecules and a mole of atoms. So in a very similar way, I have got 3 atoms of chlorine, 3 atoms of hydrogen and 3 molecules of hydrogen chloride, and those 3 molecules of hydrogen chloride are made up of 6 atoms, 3 chlorine atoms and 3 hydrogen atoms. And I can just turn these into moles, and I start with 1 mole of chlorine atoms and a mole of hydrogen atoms, and I produce a mole of hydrogen chloride molecules, which is made up of 2 moles of atoms, 1 mole of chlorine atoms and 1 mole of hydrogen atoms. So finally, let's just think about how this works in terms of equations. So now I've got the equation for hydrogen reacting with oxygen to produce water, and as we remember, hydrogen and oxygen always goes around as pairs, they're diatomic molecules to give us water. As you'll notice, that equation is not balanced, so we need to balance it up. So you need to put a 2 in front of the hydrogen and a 2 in front of the water. So if we look at that in terms of pictures, I can see that I've got 2 hydrogen molecules, an oxygen molecule, and I create 2 water molecules. I've got the same number of atoms on the left hand side as on the right hand side, but you'll notice I don't have the same number of moles, and that's really important for you to understand, because some students get a little bit confused with the fact that I haven't got the same number of moles. I've got a total of 3 moles on the left hand side. I've got 2 moles of hydrogen molecules and a mole of oxygen molecules, and I produce 2 moles of water molecules. If we look at that again in terms of pictures, I have 2 moles of hydrogen molecules. If I times what's in this box by 6.02 times 10 to the 23, I've got a mole of oxygen molecules. If I times this by 6.02 times 10 to the 23, and I create 2 moles of oxygen molecules if I times what's in this box by 6.02 times 10 to the 23. So I've now added to the number of moles that I have at the bottom there. I have got For hydrogen, I've got 2 moles of hydrogen molecules, 1 mole of oxygen molecules, and 2 moles of water molecules. So I have a total of 3 moles of particles on the left hand side, which comes to 3 times 6.02 times 10 to 23 here. And I have got 2 moles on the right hand side. That doesn't matter. I've got 3 moles becoming 2 moles, but that doesn't matter at all. The number of moles can change, but the number of atoms must not change, and that hasn't changed. I've still got 4 hydrogen atoms there, and 4 hydrogen atoms there, 2 oxygen atoms there, and a total of 2 oxygen atoms there. So that's absolutely fine. So I hope you found this useful. If you'd like to download this presentation as a PDF file, please go to my website. You can download it for free. And also there are links to other videos which you may find useful. Or just check out the website and have a look at other resources that you may find useful in your chemistry studies.